Load shedding is something that almost everyone in South Africa has experienced before, but very few people truly understand what it is. The power goes off, a stage number is announced, stage 2, stage 6. Schedules change, frustration builds. Most explanations immediately jump into words like power stations, transformers, gigawatts, frequency, the grid. For many people, those words mean very little. To understand load shedding, it helps to step away from the engineering language for a moment and start with something a bit more familiar. Let's simplify the explanation through the usage of a restaurant. Imagine a fast food restaurant with very unusual rules. The moment a customer places an order, the food must already exist. There is no waiting, there is no queue. Food cannot be prepared later. It must be immediately available as soon as the order is placed. If the kitchen cannot produce the food instantly, the system doesn't just slow down, it fails. Now, let's compare this to electricity. Chefs are like the power producers that produce or make the thing that is being consumed, the food, in this case being the electricity. The kitchen workflow and the serving counter are like power lines. They move the product from where it's made to where it is being used. Customers like you and I are the consumers of the food, the users of the electricity. You and I are the homes and the factories and the businesses that make use of the electricity. If the number of the customers suddenly increases, or if some chefs stop working unexpectedly, the kitchen that is making the food or the electricity cannot cope. Orders don't wait. The entire system becomes unstable. To prevent a complete shutdown of the restaurant, the manager does something drastic. Some customers are temporarily turned away so that the restaurant can keep functioning for everyone else. This is exactly what load shedding is. Customers are not turned away because the manager dislikes them. They are not turned away randomly. They are not turned away to make a point. They are turned away because allowing everyone to order would shut the restaurant down completely. If that happens, no one will get the food. Recovery of the restaurant will take much longer. The entire system, or the entire restaurant in this case, will be at risk. So demand is deliberately reduced to protect the system or to protect the restaurant. Load shedding works the same way. The restaurant analogy helps to explain the idea of instant balance. Engineering systems follow the same rule, but the physical reality looks a bit different. A more technical way to understand electricity is to think of it as water flowing through pipes. Power stations, which is where electricity is produced, are like water pumps. Power lines, which is where the electricity is transmitted, are like water pipes. Homes and businesses, where the electricity is consumed, are like taps. When a tap is opened, water must flow immediately. There is no waiting period. Electricity behaves the very exact same way. The moment a light, a kettle, or a factory machine is switched on, electricity must be produced at that exact moment. In a water system, too little water means that the pressure will drop. Too much water means that pipes can burst. In an electricity system, supply must match demand instantly. You will recall my restaurant analogy earlier on. Any imbalance makes the system unstable. Prolonged imbalance between demand and supply can collapse the entire grid. In South Africa, this balance is managed every second of every day. When demand increases, especially in the evenings, more electricity must be generated immediately. When the supply drops unexpectedly, the system is pushed towards failure. Imagine several major water pumps failing while taps remain open. Pressure drops across the entire system. Pipes strain. The risk of collapse increases. In an electricity system, this instability spreads very quickly. If nothing is done, protection systems trip. Power stations shut down automatically. Large parts of the grid can go dark. Recovering from a full blackout is far worse than load shedding. It can take days or even weeks. This is why engineers act early. Load shedding is a controlled reduction in demand. It works by switching off electricity to certain areas, reducing the load on the system, hence load shedding, allowing remaining supply to stabilize. In simple terms, load shedding is a controlled shutdown used to prevent an uncontrolled collapse. It is a protective mechanism, not a failure on its own, not punishment. All countries balance electricity supply with electricity demand. South Africa's challenge is that many of its power stations are old, they are maintenance intensive, in other words, they need a lot of maintenance, and they are prone to unexpected breakdowns, one of the main reasons being that they are very old. At the same time, the demand of electricity remains high. A lot of us still use and demand a lot of electricity. Maintenance cannot always be done while stations are running, so the power stations have to be shut down in order to maintain them. And new capacity has taken time to come online. New power stations have taken time to be constructed. This means that the system often operates with very little spare capacity. When one major unit fails, there is not enough backup to absorb the shock. That is when load shedding becomes unavoidable. Load shedding stages are not arbitrary numbers. Each stage represents how much demand must be reduced to stabilize the system. Lower stages mean small imbalances. Higher stages mean large shortfalls in supply. Stage 2 and 6 are fundamentally different situations, not just worse versions of the same problem. Higher stages mean more generation is offline, there's less margin of error. There's greater risk if demand is not reduced. Load shedding is often framed as a single failure or a single point of blame, but engineering systems rarely fail because of one event. They fail when multiple stresses accumulate over time. Understanding how the system works does not remove frustration, but it replaces confusion with clarity and understanding. And once the system is understood, the discussions become more informed and constructive. Hi everyone, the South African engineer here. If this explanation was useful, please like the video, subscribe, and turn on your notifications. Every subscription is a brick used to build the Engineering Explained house. Let's build this house together. Thank you for watching.